All right, hi guys. How are you people doing? So I hope the new timing is suiting everybody. All right, so here we go again. So first of all, let me welcome you guys to Unacademy's JEE English, uh, a brand new channel by Unacademy, which is India's largest platform for online learning as far as JEE is IIT JEE is concerned. And on this new channel, everything is being taught to you completely in English, so that no student feels left behind. So this series that I'm hosting daily at 9:15 is aimed towards 2020 aspirants. All right, so I take up topics and we go and have a quick recap of all the key concepts and we focus on problem solving tricks and tips. Hello, Moisha, how are you? So if you could just let me know quickly if my volume is fine, if I'm properly audible, then I'll move forward. Just let me know good to go. Just write good to go in the chat if the voice and the volume are fine. All right, great. So today we'll be talking about general motion. Till yesterday we were talking about the pure rotation of rigid bodies. Today we'll be talking and analyzing about general motion of rigid bodies. Okay. So before we get started, let me introduce myself one more time. My name is Rohit Dixit. I studied mechanical engineering from IIT Delhi. I have been teaching for more than 7 years now, wherein I've already taught at many of the biggest names in the IIT JEE coaching industry. I myself was JEE rank 447 and I've coached many students to such top ranks. And let's hope I can continue to do that with you guys on the new online platform provided by Unacademy. So, how do you make the most of this platform? So, you need to get your Unacademy subscription for that. Why? Because it comes with a lot of benefits like live classes, you get to interact with your educators, then you have live polls and leaderboards, you have test series and analysis, and you have live doubt clearing sessions. So, trust me, Unacademy is trying to provide you a complete experience of an offline class in this lockdown period, all right, at the comfort and safety of your home. And on top of all these benefits, you also get access to India's best educators with your Unacademy subscription. So, how do you get this subscription? Very easy. Follow these simple steps, install the app. Once you've done that, go to the plus section, click on IIT as your goal, and click on that get subscription button. That is how easy it is. Now, if you look at the pricing, it has been kept very modest and very fair. Unacademy is providing you quality education at a very affordable price. So 12-month and 24-month subscriptions are the most economical for students. Alright, if you notice that 24-month subscription comes at a cost of around 1500 a month, which is barely 50 rupees a day. Much smaller than whatever you guys must be paying elsewhere. Now, this already affordable subscription can get even more affordable if you get the subscription using my code, which is RD Live. So use this code RD Live. This will give you an additional 10% off. Now, also remember to join us on the Telegram app using the link shown above so that you get the notifications of all these sessions and schedules that are being hosted on the JEE English channel. Alright, so a lot of you guys had been asking me to create my own group also. So I've created this group, a Telegram group. You can join this group with the link shown above. The name of the Telegram group is JEE Physics, and you can also find me on the Telegram app. My username is Rohit_Dixit. Okay, and that's the spelling. So I know a lot of you people had been requesting about this, and you said that you are unable to find me. So now you can find me using my user ID. You can also join me on this group called JEE Physics for any doubts and discussions. Okay. Now please remember about the new timings that we have been following since this Monday. In case you haven't got a hold of this timetable, here it is for you. So I'm hosting sessions all 6 days a week, and 3 days for 2022 students at 4 o'clock, 3 days for 2021 students at 4 o'clock, and daily for 2020 aspirants at 9:15. Alright, so get your timings from there and do not miss any session. No problem, Maisha. So let's get started with today's lecture without any further delay. So last time we were discussing about dynamics of pure rotation, and I had given you a practice problem to be solved at home. Alright, so let's go over this problem once. So did you get a chance to try this at home, Moisha? Were you able to solve this? Please let me know if you tried this problem and if you were able to solve this, or in case you ran into a difficulty. Why do I have a feeling you didn't try? Because of I knew it, because otherwise the response would have been faster. Alright, so try this later, and if you think that this needs to be discussed, now you know where to catch hold of me. You can catch hold of me on the Telegram group. Okay. So, anyways, in that case, I'm not going to discuss this. However, I did want to discuss this one problem. So, here, this is your normal pulley mass problem with some variation. The variation being that your pulley this time has a mass. Okay, so it's a disc of mass capital M and radius capital R. So, let's try this problem. Okay, so you've been told that two blocks are connected by a massless string moving over a pulley of mass capital M and radius capital R as shown in the figure. You have to find the acceleration of both the blocks and the tensions in the string of both these sides as shown in the figure. So here's your figure so that you can have a look at it properly. So you have to find the accelerations of both the masses and the tensions in the two strings. Alright, great. Good to know. So solve this problem. Let's see how much time you take. And then I will show you a super trick for this. Okay, I'll show you a super trick with which you can solve this in under 20 seconds. Alright Ankit, how are you doing? Good to see you here. It's a good thing that some of you are following these lectures regularly, because to make the most out of these, you need to follow all the lectures. If you start missing lectures in the middle, then trust me, you won't be able to follow all of them. So make it a habit that you're following all the lectures on a very regular basis. Okay? Just like Ankit and Moisha do all the time. Alright, so I hope all you guys are trying this. So others who've just joined, let me repeat the question. The question says that two blocks are connected with a massless string moving over a pulley of mass M and radius R as shown in the figure. Find out the accelerations of both the blocks and the tensions in the string on both the sides as shown in the figure. So here's your figure. I hope all you guys can see this clearly. And I will solve this with two methods. One, the traditional method, which you see all the time, which all your teachers tell you, with all your books tell you. And then I'll show you a super trick. I'll show you a super trick which will help you solve this problem. I mean, I can solve this problem in under 10 seconds. But you will be at least able to solve this in under 20 seconds. With some practice, you will also be able to solve this under 10 seconds. Alright. So pay close attention, because the tricks that I'm telling you, you're not going to find them anywhere. These were my personal creations. Okay, when I was a student back in the day, just like you guys, when I was preparing for IIT JEE exam, I found, or rather, a lot of shortcuts. So I'm sharing you these shortcuts which I came up with from my personal experience and practice. Okay. So let's see. Trust me, the methods that I will teach you here will help you a lot in saving a lot of time. All right. So here's the question. All right, you have two blocks, as you can see, which are hanging from a pulley which has a mass, and the system is released from rest. Now you have to find the accelerations of both the masses. Actually, I can solve it by three methods, by the way. I can solve this problem by three methods. So you guys can take a pick which method you want to use. back when I was preparing for my IIT exam, I remember the content that we used to have was pretty limited. I mean, we did not have such wide variety of content available over the net. I'm good, Samarjit. How are you? So try. Why don't you try this problem? Then I'll show you a very nice shortcut for this. So I remember when I was preparing for IIT JEE, back then in the early 2000s, not a lot of content was available online. Of course, I mean, we guys hardly had access to good speed internet. So forget about having anything online. So the content that we had was very limited. Okay. Thank you, thank you, Samarjit. So I remember, I think we were limited to 2 3 books only. So I just referred to 3 books. One Resnick Halliday, another H.C. Verma, another Erudov. That's about it. I solved these 3 books. So I had taken a drop of 1 year after my class 12th, and I prepared for IIT JEE exam during that drop only for 1 year only. So I remember I finished all these 3 books within the first 6 months, I guess. So for the next 6 months, I was feeling pretty bored. So I started solving all the problems with a new agenda. I thought, okay, I'll solve every problem, but this time I'll solve the same problem with a new method. All right. So I tried solving every problem with a new method, which I hadn't used when I solved it the last time. That is how I came up with a lot of methods to solve one problem. I can solve almost every problem using at least 2 to 3 methods, at least 3 methods rather. And that is when you start discovering a lot of shortcuts. You realize that there are some tricks, some shortcuts that you can use for problem solving. So I'm still waiting for an answer. So you realize that this is a problem which takes some amount of time in solving because I still haven't got an answer yet. And it's been almost 5 minutes since I have given this problem. Moisha, are you still on this problem? Samarjit, I would also encourage you to try this, please. Alright, try this problem, guys. Oh, you did? I somehow can't see the answer that you posted. I can't see the answer that you posted. Can you post your answer again? And I know the answer because I just solved it. So I'll be able to check right away. So if you can post your answer one more time, because I don't know, I can't see the answer that you posted earlier. Okay, till the time Moisha posts the answer, let's try and solve this. So I'll show you all 3 methods. All right, so let's go over method number 1, which is the most traditional method of solving this problem, which is what you would have been told at most of the places. So let's try and solve this by method number 1. So method 1. The situation that you have is that you have a pulley, you have a mass m1 here, you have a mass m2 here, and then this pulley is hanging from here. This pulley has a radius of r and a mass of capital M. So what you do is you start writing the equations for translation and rotation of the pulley. Alright, so you assign some tensions here. Let's say the tension here is T1, tension here is T2. So first let me write equation for M1 and M2. So I can write for M1 and M2. What do I know? I know that I'm assuming at this time that M1 is going down with some acceleration A and M2 is going up with some acceleration A. Okay, and the pulley of course would be turning like this with some angular acceleration alpha. Okay, so let's see what equations I have. So for M1 I can write M1G minus T, T1 would be equal to M1 times A. So that's my first equation. The second equation that I have is for M2, which will be T2 minus M2G equals M2A. Right. Third equation I will write for the rotation of the pulley. So if I make the free body diagram of the pulley and take all the talks about its center, so I realize there would be some force from this string, 1 mg, then I have T1 acting here, then I have T2 acting here, and some T3. So if I take the talks about the center of the pulley, let's say C, I only get the torques due to M1, T1 and T2. So let's see, taking torques for the pulley about C. Let's see what we get. We get T1R minus T2R equals I times alpha. Okay. So what is the I of the pulley? Pulley is treated as a disc, circular solid disc. So I can be written as mr square over 2 times alpha. So that becomes my equation number 3. Okay. So from here I can cancel out the r's on both the sides and I can say that T1 minus T2 equals mr alpha over 2. That's equation number 3. Now I realize I have 4 variables. Variables being T1, T2, A and alpha. So I need a 4th equation as well. Alright, so what is my 4th equation going to be? I know that this point would accelerate downwards with A. So the tangential acceleration of this point is A and the angular acceleration is alpha. So I know the relation between the tangential acceleration and the angular acceleration. So how can I relate those? I can write my 4th equation by relating the tangential and the angular acceleration as A equals alpha r. So that is my equation number 4. Now I can solve these 4 equations. Alright, so let's see where this lands me. Alright, so let's substitute the value of alpha into r from here to here. So I get T1 minus T2 equals capital M A over 2. Alright, now let's substitute this value over here. What happens if I subtract equation 2 from equation 1? Or maybe let's add these equations. If I add equations 1 and 2. So adding equations 1 and 2, let's see where that lands me. That will give me M1 minus M2G minus, I am writing it with a minus sign, minus T1 minus T2 yeah, that is what it will look like, equals M1 plus M2A. Alright, now I will substitute this value of T1 minus T2 over here. Let's see what we get from that. What I am getting is M1 minus M2G equals, on this side, I am taking this to the other side of the expression. So I will get M1 plus M2 plus M by 2 times A. So final expression of A that you have is 2 M1 minus M2 G over M plus 2 M1 plus 2 M2. Alright, that is my final answer. So I hope that is the answer that you got. Maybe I can rewrite this on the side. So final answer that I am getting for my A is that A equals M1 minus M2G 2 times over M plus 2M1 plus 2M2. Alright, that is my answer for A. You will realize that there is a lot of working and there is a lot of equations involved. So 4 equations, so much of working, and finally I get my answer. Good evening to you, Hitesh. So please let me know, Mahesha, if this was the answer that you had, because I still can't see your answer. Alright, good. Okay. Okay, sorry. My net got disconnected for a bit, but I think we are fine now. Alright, so is this how you did this? Moisha, how did you solve this? Did you. Now I understood about the screening test. Okay. Alright. So is this how you solved this, Moisha? And also let me know for the benefit of all that how much time did it roughly take? So go through the solution. Alright, you did it using energy conservation. Yes, that is the second method that I was going to tell you about. Very nice to see that you use energy conservation. This is the most traditional method of solving this. Alright, so I hope everyone has gone through this method, because now I will solve this same problem using a second method, and then finally, as my method number 3, I'll show you a trick which will help you get the answer within 10 seconds or within 20 seconds at least. Yeah, I know, me too. Everybody hates equations. Alright, so this was using Newton's laws and tau equals I alpha. Second method is using energy conservation. Alright, so if you have had a look at this solution, I'm going to rub it off completely. I will let the answer be there. Alright, the final answer, let's leave it there. Alright. Now, method number 2. Method number 2, I am going to apply energy conservation. Okay. So let's talk about method number 2 now. So in method number 2, what I'll do is that I'm saying, alright, so let's say that this system is initially released from here at rest. Okay. So here's my M1, here's my M2. So, and initially the pulley is also not rotating. Right. Now, after some time, when this goes down by some distance x, this reaches here. So it has shifted x downwards. What will happen to the other guy? So this has reached here, and this would have reached here. It would have moved upward by a distance x. And I'm assuming at this time, the speed is v and acceleration is a. Now this guy will have an upward speed v and upward acceleration a. Alright. And of course at this time this guy will also be rotating with some omega. Okay. So this is your Rm. So that is what the situation will look like once M1 has descended by x and M2 has gone up by x. So let's try and analyze this. You realize that there are no non-conservative forces acting on the system. The only force that is doing the work is the force of gravity. That is what is providing all this kinetic energy. So I can apply energy conservation here. So let's say that this was situation number 1 and this was situation number 2. Let's try and write the expression for energies in situation number 1 and situation number 2. So what can I say? What is my K1? K1 is 0. K1 is the kinetic energy, total kinetic energy of the system in my first situation. In the first situation, everybody is at rest. The disk is not rotating, the masses are at rest, so the kinetic energy is 0. What about my potential energy? I am taking this as a 0 reference line for u. So I am taking u to be 0 here. I told you this, that you can take any height as your reference point for 0. So if I take this as my 0, and that's just convenient. So my potential energy for the two masses also comes out to be 0. Plus, yes, this guy would have some potential energy, but I'm not bothered about that because the potential energy of the pulley never changes. Then pulley will never move up or down. So I'm not bothered about writing the potential energy for the pulley. So this is for situation 1. Now let's talk about situation number 2. What is the kinetic energy? So mass M1 is moving with some v, so it has a kinetic energy of this. Mass M2 is also moving with v, so that has a kinetic energy of this. And also the disk is rotating. So the rotating disk will also have a kinetic energy, and we know how much that is going to be, half ICM omega square. So half I omega square, I would be mr square over 2 times omega square. Okay. Screen ID. Screen ID for Telegram ID is Rohit underscore Dixit, by the way. If you want to find me on Telegram. Similarly, let's talk about U2. What is the potential energy in the second stage? Mass M1 has come down by x, so I can write this as minus M1 Gx. M2 has gone up by x, so I can write this as plus M2 Gx. Alright. And I can also write that this point would be moving with a speed v. So I can write another equation suggesting v equals omega r. Okay. So once I have these two equations, one this and all the energy expressions, I can apply energy conservation. So let's see what that. Yeah, I will reduce it once I'm done writing. Alright. So let's apply energy conservation. Applying energy conservation, let's see what does that give me. So applying energy conservation, I can say that K1 plus K2 plus U1 should be equal to K2 plus U2. Alright, let's start substituting values. This side, on the left hand side, I'll have all zeros. This should be equal to half M1V square plus half M2V square plus half M. Now you realize I will substitute R square into omega square as V square. So half M by 2 V square. And then I have minus M1Gx and plus M2Gx. Alright, so now I need to rearrange the coefficients. So when I do that, let's see what I'm getting. I am getting M1 minus M2 times Gx equals, and I'm taking V square common from all this. So if I take V square and half common from this, so I can get half M1 plus M2 plus M by 2 times V square. So this is the expression that I got from energy conservation. Now there is only one step left. So you differentiate both the sides with respect to time. Menti quiz, I'm organizing Menti quizzes only for 2020 aspirants and 2021 aspirants and 2022 aspirants. I don't think 2020 aspirants have the time for Menti quizzes. Okay. So, but I will be, whenever I take this topic up for class 11th, I will organize a Menti quiz. Okay. So now differentiate both sides with t. With respect to time. Let's see what that gives you. So M1 minus M2 g times the derivative of x with time would be v. Right? dx by dt is nothing but v, the speed. Similarly, here what I am getting half M1 plus M2 plus M by 2. Okay, let me write that again. So plus M by 2 times derivative of v square, that would be 2v into dv by dt. dv by dt is nothing but a. Alright, now I can cancel out these and I can cancel out these, and what I get is my a as this. I will get my a as this, if you notice. Alright. I hope you guys followed this method. Let me move aside a bit so that you can see what is happening. Alright, great. Okay, mate. So for 2021 aspirants, I am conducting series for class 12 syllabus. If you want quizzes for class 11th syllabus, then you can follow my class 11th series also. So let me know if you followed the method number 2. This is again still an exhausting method. This again required a lot of working. But yeah, you did not write a single F equals ma equation or a single tau equals I alpha equation. You got everything without those expressions. Okay. Let me know if you followed this method. Did you guys follow this method? Method number 1 is the most commonly used method. Okay, so that is why I did not take much time with that because. All right. How about the others? Now let me show you method number 3. Method number 3, trust me, will shock you. Okay, so I am rubbing this off. You can watch it later in case you missed some part. I'm rubbing this off completely. Now let's talk about my favorite method of solving this. So yeah, we got rid of all this. And now let's talk about method number 3. Alright, so just one small question. Do you think the answer for acceleration will change if I change this length? If I double this length, do you think the answer for acceleration would change? Do you think the answer would change if I change the length of the string? If I made the string longer or maybe shorter, do you think the answer would change? Suppose I had this situation, I had longer strings, then you think I'll get the different answer, or if I had shorter strings, would the answer be different? No, of course not, right? That is what I base my second method on. So in the second method, the trick that we use is that we make this length of the string 0. Yes. Make the length of the string 0. Now let's see what you have. Now you have a very simplified case. Yes, Moisha was quick to catch on to that. So if you make the length 0, so here is your M1, here is your M2. What are the forces? Here M1G, here M2G. Alright, now all you need to do is take the torques about the center C. So this was M, R and this was your center C. Take torques about C. Taking torques about C. Let's see what that gives you. You have the torque M1 minus M2 G times R. That is the net torque that I'm getting in this direction. This should be equal to the total I of the system times alpha. The total I would be the I of the disk plus I of these point masses hanging on the edges of the disk. So the total I becomes mr square over 2 plus m1r square plus m2r square. This times alpha. Alright, so you can remove all your r's and take out one more r common. You also know A equals alpha r. So you realize what you get, m1 minus m2g equals m by 2 plus m1 plus m2 times A, which gives you this. Alright, that's the quickest method of solving this problem. I hope you guys followed this. You see, there is hardly any working. All I needed to do was write one expression for torques and then use the fact that A equals alpha r. And I got this so quickly. Yes. That is what I'm doing. Instead of only the moment of inertia of the disk, now my system contains a disk with 2 point masses attached to its edge. So now the I of the system would be moment of inertia of the disk plus moment of inertia of both these particles. Yes, absolutely. Why not? Vinod. Alright, I hope you guys followed this method. This method you will realize hardly had any calculations, just used a simple trick and you got your answer almost in 2 lines. I mean, with enough practice, I can do this orally also. Just write the net torque and write net torque over net moment of inertia. Of course, into R also. Alright. So let me know if you guys followed this method. And you saw this solution. The solution is obviously way shorter. No. you don't do that. Why? There is a reason. Here you could take this as one system. Why? Because all the objects will be moving with one alpha. You can apply it in other systems also. But you have to make sure that all the particles should be moving with a single alpha. I don't have any questions right now with me, but I can solve like 4 or 5 questions of HC Verma using this trick. But there is one case I think where you can't. Let me remember. I think I remember one question which can be solved using this method. Okay, so that I will show you. So first, let me know if you followed this method. If you followed what I did here, then I'll move on to a next question and I'll show you how this method can also be applied there. Let's just focus on this one first. I'll come to the other variations where also you can use these tricks. And then I'll show you a case where you can't use this trick. Alright, great. So, I think I need another sheet. Maybe I'll just do it here. Or maybe here, yeah, this is vacant. So I remember there was also one question in HC Verma which goes like this. Okay, so in that question you have one pulley of radius r and mass m, and you have a mass hanging from here m1. Then this goes to a different pulley and you have another mass hanging from here, and this is also identical pulley m and r. You can have the masses of the pulleys different also, but the radii should be the same. Alright, the radii should be the same. So if you have this question and you wanted to find out the acceleration, again you combine all these 4 objects into one, because all of them will have a single alpha in that case, right? So I can combine this into a single thing, a disk of mass 2m and radius r, and m1 hanging from here and m2 hanging from here. Alright, so I will immediately get the answer for this. You can check this problem out. This is in your HC Verma. So now you immediately know what your answer should be. You know that the net torque is m1 minus m2 gr, and that should be equal to 2m r square over 2 plus m1 plus m2 times r square times alpha. So here you will get your A as m1 minus m2 g over m plus m1 plus m2. That is it. Yeah, you could have done that. You could have done that. Yes, Moisha, you can do that. In fact, you will see that that works. That works if you can do that. Yes. But I didn't want to get into it because I'm not sure if everybody will be able to follow what I'm trying to say. Alright. But yes, you are absolutely right. So for this, the answer is straight away this. Okay. So you guys can check out this problem. This is a problem in HC Verma, I think. Sorry. Now you will realize it doesn't even matter if the masses of the pulleys were different. Even if this was M1, even if this was M2, instead of M here, you would have had M1 plus M2 by 2. Okay. I hope you can see that. Even if the masses were M1 and M2, even if the masses of the 2 pulleys were different, then also all that would have changed in your answer. Instead of M, you would have had M1 plus M2 by 2, because you would have written here M1 square by 2 plus M2 square by 2, M2 r square by 2, M1 r square by 2 plus M2 r square by 2. So you would have landed with M1 plus M2 by 2 instead of M. Now the case that I was talking about. Alright. Suppose I have another variation. The variation being that, okay, I have 2 pulleys, but this time one pulley is smaller and one pulley is bigger. Alright, so here I have a problem. Here this pulley and this pulley will not have the same alpha. That is why you can't directly apply this. You have to do some manipulation, as Moisha said rightly. But you can't apply this directly with that kind of ease with which we are using it so far. So this is another problem in your HC Verma, where one pulley has a radius r and another pulley has a radius of 2r. Alright, so here you can't apply that formula directly. Why? Because see, in this case, when I am combining this into one single unit, all the terms, all the masses have the same alpha. Okay. Alright, so in the earlier case, I will realize once I make this system, a single alpha would have given me the accelerations of m1 and m2, and single alpha would be there for this guy and this guy. Here I will realize this, if this has alpha angular acceleration, this has 2 alpha, and this has 2 alpha r, and similarly this has again 2 alpha r only. These two have to have the same acceleration. Alright, but these two don't have the same angular acceleration. So that is where you will face a problem. You can't mount m2 over m1 directly. Alright. So there you may have a problem. So you do not use it here. Alright. See, I'm not going into the details of how you can manipulate and use it for this also, because I don't think there is so much time for you to, talk about so many manipulations right now. You guys are 2020 aspirants. So this trick does not require too much. This does not require too much. You don't have to use anything new here up till here. All you're doing is converting all these bodies and making it a single unit. Okay, for manipulation of this, again, you need to learn something new, which I don't want you guys to be doing right now. Right a few months before your JEE exam, it's not advisable to be trying entirely new things. You can improvise on what you already know, but trying entirely new things, that I don't think is too beneficial. Good evening, Gauranj. Alright, so I hope you guys followed these tricks and you realize that these tricks will help you save so much of time. Now you can revisit your HC Verma, solve your problems of pulleys with masses using this trick, and you will see how easily you get your answers. Okay. Next, for pure rotation analysis, I can also use work and energy analysis. Alright. So I can use my work energy theorems. So work done by a torque is calculated as integral of tau dot d theta. Now in your syllabus, as far as IIT is concerned, in your syllabus only single omega systems have been specified in the syllabus. So omega has to have only one direction, and that is why any torque which is producing that kind of omega has to be along the same line of that omega. Alright, so that is why I am rewriting this like this. Because as far as JEE syllabus is concerned, you will not talk about any torque which is not in line with the theta. In case there is, then you use cos theta, of course, but otherwise in most of the cases, so this is most of the cases, the angle would be 0 and the equation would be reduced by this. Similarly for power, it's not too complex. I mean, we use it in COM. Yeah, it is something like that. I agree. It is something like that. But again, again, as I said, for that you need to have a very good understanding of everything else to start using these manipulations of situations. At an advanced level, you need to have a very good in-depth understanding of all your concepts. That is why I did not want to go through that. All right, because I'm not sure if everybody would feel comfortable about all the manipulations. Yes, theoretically you can do that. If you have a good understanding, definitely you can come up with more shortcuts also. Like this is just what I discovered when I was solving problems. So right, it's not like you guys can't find other methods also. But for 2020 aspirants, I'm not advising it right now. Alright. For class 11 people, when I will be taking this same class for class 11 people, I would encourage them to, think like this. I mean, think out of the box. Don't go by the traditional answers here. You are free to understand your concepts, apply them in any which way you feel like. Alright, so that is the idea. If you understand your concepts, then you can do these manipulations and arrive at different shortcuts. Okay. So I would advise that from right from class 11th only, not at such a late stage though. Anyhow, so power, similar to work, I can define power of a torque. Power of a torque is given by tau dot omega, and kinetic energy of pure rotation we already discussed is half I omega square. So I can apply my work energy theorems also for analysis of pure rotation. So let's see an example where we apply work energy theorem. Alright, so let's try this problem. So you have been told a meter scale AB is held vertically with one end A hinged on the floor. It starts falling on its own from rest. Thank you, Ankit. Alright, so it starts falling on its own from rest. You'd find the velocity with which the end B will strike the floor. So this will rotate, it will start falling, it will accelerate, and then when it hits the ground, with which speed does point B hit the ground? That is what you are supposed to calculate. Okay, so please try this problem and do let me know that you're trying by writing trying in the chat. Okay, just quickly write trying in the chat so that I know you guys are trying this problem. We've already taken a lot of time in the previous problem because I originally did not intend to show you all three methods. But then I thought unless I show you all three methods, you won't be able to appreciate how much better the shortcut is, how much easier the shortcut is. And remember, before using the shortcuts, you also need to know your longer methods. Okay, so don't just think okay, you can forget about your regular normal methods and you can only use shortcuts all the time, because unless you know your long methods, you don't know where your shortcuts are coming from. So you won't know where you can apply them and where you cannot. Every shortcut will have some limitations. Okay, it can't be directly applied anywhere and everywhere. So you need to realize that. That is why you need your longer methods also. Once you're comfortable with longer methods, then yes, you can go for shortcuts. I know most of you do not like the lengthy problem solving. Every time I solve a problem which has a solution which is big, I see my live viewer count going down instantly. But guys, this is something that you will have to get used to. I mean, you can't think that you can get away with hard work. If some problem has a longest solution, then also you need to solve it. All right. This should be very, very simple. This is not too complicated. All right, I'm still waiting for an answer. You need to consider the length, or do you? Maybe the length will get cancelled out. Yeah, length will get cancelled out. Maybe no. I think the length will figure in the answer. So, length you already know. It is a meter scale. Right. That's what I was wondering, why the length is not mentioned. All right, hurry up, please. The mass obviously is not needed because the mass cancels out. Yes, I know, I realized that as soon as I said it. All right, please let me know as soon as you've solved this, and please post your answers as soon as possible. Moisha, so for some reason I couldn't see the last answer that you posted, so try posting your answer. And as soon as you've posted your answer, also let me know that I have given the answer, so that just in case your answer doesn't appear, I know that you have given your answer, and for some reason it is not appearing. All right, because I think by now you should have had the answer. Who will apply a torque mg will pass through the hinge. I will take torques from hinge. Uh, what is that supposed to mean? You don't need to solve this using torques. Your work energy analysis will help you. Oh, are you talking about the initial stage? Initially, just imagine that this was given a small push. It was given a small push. So the moment it's given a small push also, then mg will take things forward. Then mg can give a torque. Yes, initially of course it was resting like this. Imagine that I gave it a slight push. A slight push. Then mg will take care of everything. Okay. Yes. Of course. To initiate the motion, you're supposed to give it a slight push. So you can assume that I did that. I gave it a slight little push. Then yes, once this is not perfectly vertical, even if there is a small angle d theta here, now mg will take care of things and this will fall. Alright. So solve this quickly and give me the answer quickly. I don't expect you guys to be taking so long in answering these problems. If you're 2020 aspirants, that is. Varsha, are you going to take your JEE exam in 2020 itself? If yes, you need to start working on your speed. You need to be faster and problem solving. Trust me, that matters a lot. And of course, you have to maintain a balance between speed and accuracy. Just increasing speed doesn't mean that you start solving everything in such a hurry that you end up getting all your calculations wrong. Okay, no problem. No problem. The hinge can be assumed to be completely frictionless. So that does not do any work. So consider hinge to be frictionless. Okay. Square root of 60, let's see if that answer is correct. So this is my initial position, this is my final position. Here, while writing the potential energy, please note that we take the height of the center of gravity. Okay, because that is the average position of the weight. Yes, yes, I got that. So your Cm in this case would coincide with your Cg where G is uniform. As far as gravity or acceleration due to gravity is uniform, your Cm and Cg are always the same. So here it is at a height of L by 2. I will later substitute the value of L as 1, and here it is at ground. So I can directly apply energy conservation, and I can say that all the potential energy lost in moving from here to here would have gone into the kinetic energy of the rod when it reached here. So if at this time the rod is rotating with an angular velocity of omega, yeah, you did not write L by 2, did you write L? That is a common mistake. So mgl by 2 would be equal to half I omega square, and I about this one end of the rod is ml square by 3 into omega square. So that is what your energy conservation would give you. Loss of potential energy equals gain in kinetic energy. Loss of potential energy is mgl by 2. Gain in kinetic energy, initially the kinetic energy was 0. Finally the kinetic energy is half I omega square. I would be ml square by 3. So please notice some things that why not take off the topmost point? Because when you're writing the potential energy of the system, see, when you're writing the potential energy of the system, you have different masses. You have a mass dm here at some height x, then you have another mass, let's say dm dash, at some other height y. So all the masses are at different heights, right? So when you're writing the potential energy of the system, you need to find the average height of the mass. The average height would be in the middle. I hope you realize that. So the average height of all the masses would come at the middle. So you can imagine all the mass m to be kept at L by 2. No, you cannot. No, you cannot. No, you cannot. There is a reason for that. See, if you only talk about this point, the forces acting on this point are not only mg. Let me show you what I mean. Consider a point when this is like this. Now you see mg is acting like this, but this guy is moving like this. So why do you think it is moving like this when the force is this? Because there must be internal forces. There must be some internal forces acting on it. Yes, those internal forces will do some work on it. That is why the kinetic energy of this is getting transferred to the rest of the masses also. The internal forces are doing work on different masses. Okay. So since you do not know the work by internal forces, you cannot apply work energy theorem or energy conservation, because there are external forces which are doing work. Alright. Unless you can find work done by these forces, everything becomes external for this point mass. Even the force by the surrounding mass is an external force for this point mass. Okay, that is why only if I consider this entire object to be one, then all the internal forces I know will not do any work. Alright, so then I can apply this. So the moment I apply this, I will get my mg get cancelled, 2 get cancelled, L get cancelled, and I am getting the speed I was supposed to calculate. So let's find the omega first. Omega comes out to be 3g over L root. Alright. So L is 1. So omega I am getting as root of 30. And since the length is 1, speed of B would be omega L, which would be root 30 meter per second. Alright. So please pay attention to all this. When you're writing the potential energy of the entire system of bodies, then you have to do this. Alright, take the potential energy properly. Okay, so that was the solution of this one. Now let's begin our analysis of general motion. Yes, L is 1 because it's a meter scale. Alright, now let's begin the analysis of general motion. This is everything that I wanted to discuss about pure rotation. Now, as you can see, any general motion can be seen as sum of translation and rotation. So earlier you had pure translation and then you had pure rotation. Now what happens if you combine both these? Then that is what you have general motion as. So general motion is this guy going like this. Alright. So this guy going like this can be thought of this guy going like this first and then this guy turning like this. Okay. So as you can see in the figure, when this guy moved and turned like this, you could have thought that first A moved in a straight line like this and then the entire rod turned about A. So every general motion can be seen as a combination of a translatory motion of any point of the body and then the rotation of the entire body about that point. Right. So that is what our approach is going to be. Yeah, I know there might be some problem with the net. I don't know. My net also seems to be glitching a bit. Anyhow, so as I said, any general motion can be seen as a combination of a pure translatory motion and a pure rotation. These two motions are mutually independent. That is what you need to remember. That is what is very, very important. That the pure rotation and pure translation in a general motion are mutually independent things, which means one does not affect the other. So that is the idea that I'm going to use for analysis. You remember how did we analyze 2D motion? Any 2D motion I would break into two 1D motions. One motion along X, one motion along Y. And the reason why I can analyze them separately is because the motion in X and motion in Y are mutually independent. They do not influence each other. So since the pure rotation and this pure translation would also be mutually independent, I can analyze them separately. So remember this, when I'm analyzing general motion, I will break the general motion into two motions, one translation and then rotation. Okay, so any motion like this can be broken into one motion like this, one motion like this. Now, because these motions are mutually independent, when you are analyzing translation, you can completely forget about the rotation. Similarly, when you are analyzing rotation, you can completely forget about translation. Now, you already know how to analyze pure rotation and pure translation. Now, you just do it one by one for general motion by forgetting about the other one at the time of analysis. Then you can say the final result would be a combination of the both. Okay. So that is the idea. We can analyze the translatory motion of any point of the rigid body, by the way. As you can see here, I have broken this motion into the translation of A and rotation about A. Right. So it's not necessary that we do it for CM only. I can do it about any point. I can see the translation of any one point. I could have also done this like this. I could have moved this in a straight line and then rotated this rod about this point. I hope you guys are following that I can look at translation of any one point and then rotation about that point. Right. So I can choose any point lying on the rod, initially focus on its translation, and then I may add a rotation of the rod about this point. So since this is a point on a rigid body, you realize what is the property of a rigid body? In the reference frame of B, the entire body will appear to have pure rotation about an axis passing through B. In the reference frame of A, everything will appear to be rotating about an axis passing through A. That is the property of rigid body. I have already discussed this. So there should be no confusion about that. Now, which point should I pick to analyze its translation? The easiest is CM. Okay. Why? Because as you would have realized from the last example also, suppose I wanted to analyze the motion of point A. Now the problem is that motion of point A or mass at A, let's call it MA, is dependent. It has forces acting internal also, F internal, and as well as it may have some F externals. Now the problem is that motion of every point on the body will be dependent on the external forces as well as internal forces. Now you realize it is almost impossible to figure out what internal forces might be acting on MA. That is why it will be very difficult for me to analyze the translatory motion of A, mass A. However, the thing about CM is that CM's motion is only governed by external forces. So the motion of CM is the easiest to analyze. So that is why we break it like that. The easiest approach is to analyze the motion of CM and then pure rotation of the rigid body in the reference frame of CM. That is what my problem solving strategy is going to be. First of all, I will look at all the external forces. Why? Because CM's motion is independent of internal forces. The net internal force acting on the CM is always zero. Okay. So that is a fact that I know about CM. That is why I will analyze the translatory motion of the CM and then I will go to the reference frame of the CM. Now the moment I go to the reference frame of the CM, even when general motion is happening, so the moment I enter CM's reference frame, what do I see? I see the CM as stationary and the body in pure rotation about an axis passing through CM. So that also I know how to analyze. So that is how we are going to analyze any general motion. That is the basic approach, that is the general idea. Alright, now let's talk about the problem solving strategy. So how do you analyze the motion of CM? Very, very simple. You write all your F externals and you know that summation F external equals M ACM. You immediately know ACM from here. Secondly, when you come in the reference frame of the CM, you write all the torques, summation of all the torques about CM equals ICM alpha. Why am I using that equation? Because in the frame of CM, the body will always have pure rotation only. No, F internal will not become 0. Its torque may be 0. Its torque may be 0. Moisha, there is a difference. I am talking about analyzing the translatory motion. Understand this. I am talking about the translatory motion, not the rotatory motion. If you look at here, if you look at point B, MBG was acting here and some internal forces were acting which were causing an acceleration in this direction and in this direction, right? So I'm not talking about the torques, but I'm talking about the acceleration. See, if this guy moved in this manner, then the net force has to be in that direction, right? Okay, consider one thing. Consider one thing. This is here. Alright, I am moving this end. What force moved the other end? There was no force acting on the other end, right? If I take this and I am applying only a force on this end, this being end A, what caused the motion of end B? There were internal forces. Okay, there is no external force acting on this end, but it's still accelerating. And F equals ma tells me that there has to be a net force on this end for it to accelerate. What was that net force? Those were the internal forces that are causing the acceleration. Now, if I did not know about this force, and if you ask me simply to find the acceleration of this guy, it would be impossible for me because I don't know how much internal forces are acting. Okay. So I am talking about the translation. The translation of points would be easiest to analyze from CM. Yes, rotation you could have analyzed from any point, but the translation of CM is the easiest to analyze. That is why I will solve the entire problem from the reference frame of CM and the analysis of CM. Hi Sudarshan, how are you? Alright, I hope your doubt got answered, Moisha. Hello Sudarshan, hello. Be a little patient, there is a slight lag, when you type in your message and when I see them, there's a slight lag of a few seconds, so don't worry, be a little patient. Alright, so once I have figured out the ACM, from here I know what my ACM is. Next what I do is I go into the reference frame of the CM. Now from the reference frame of the CM, I see a pure rotation about an axis passing through the CM. So that is why now I write all the torques about the CM and then I equate it to ICM alpha. Yes. That is the problem with all other points except for CM. If you want to analyze the translation of any other point except for CM, the problem is that their motions are governed by external forces as well as internal forces. And since you have no information about internal forces, you won't be able to analyze them. Okay. Now, please note, I had told you that you can use this equation about any inertial point for pure rotation, right? What happens if your CM is accelerating? In this case, you realize your CM is accelerating. So when I go into the reference frame of the CM, it is a non-inertial reference frame. It is a non-inertial reference frame. So, can I still apply this or should I be adding pseudo torque? So that is another reason why it is easier to analyze things in the reference frame of the CM. That even if your CM is accelerating, even if it is a non-inertial point, there is no pseudo torque. Why? Let's say why. No, there is no pseudo torque when it comes to CM. That's the magic. Imagine a rod, it is a stationary rod. Now imagine another observer which is accelerating with an acceleration a. So this observer says that this rod is accelerating in the reference frame of this observer. The rod seems to be accelerating in this direction with a. Alright, or minus a vector. This would be minus a vector. Now, so he says, okay, why is this rod accelerating? A pseudo force must be acting. Now, at which point should I apply the pseudo force? Where is the pseudo force exactly acting? Is it acting here? If pseudo, where does the pseudo force act? Or is it acting here? Or where is it acting? So my point is, it always acts at the CM. The pseudo force that you see from a non-inertial point will always act on the CM. So please remember this, that pseudo forces always act on the CM, wherever the CM is. Okay, that is why even if my CM was a non-inertial frame, I would apply a pseudo force here, and the pseudo force will not give any pseudo torque. So there is never a pseudo torque in the reference frame of the CM. That is why it is easier to apply this analysis also in the reference frame of CM. If instead of CM I took one more point when it is moving like this, okay, so if I wanted to write the torques about this point, now this point would have an acceleration, this would have a pseudo force which will be applied on the CM. So about this point I would have to take that pseudo torque as well into account, otherwise I will get a wrong answer. So these are the two advantages of analyzing things through CM. One, the internal forces do not matter. Second, the pseudo torques do not come into play. Okay. So I can only write all the real torques, summation of all the real torques about CM equals ICM alpha. Okay. Now, using these equations, I can figure out ACM, I can figure out alpha. Once these two are known, then we can find VCM and omega, right? You know UCM. If you knew UCM, you will be able to find the VCM. All right, by simply integrating or whatever. Similarly, if you knew the initial omega and if you knew the alpha, you would be able to find the final omega about the CM. Now, once these quantities are known, all other quantities can be calculated. Let's see how. So first of all, I'm saying that velocity of any general point can be calculated if I know VCM and if I know omega. Why? Let's see, at any general point. So at any general point in the reference frame of the CM, any point is performing pure rotation. So if you had any general point A which had a position vector of r of A with respect to C, and this body was moving with some omega. So I can write the velocity of A with respect to CM. How much would that be? That would be r vector of A with respect to CM cross omega vector, right? And I also know my VCM. So I know what will be the velocity of A in ground frame. In ground frame, I know this will be velocity of A with respect to the CM plus VCM. Alright, so that is how I can find the velocity of any point now. Any point on the any general point on the body, as far as I know omega and I know my VCM. Alright, so that is the thing that I use to find the velocity of any point. Now, similarly, I can find the acceleration of any point. So first what I'll do is, I'll look at any point in the reference frame of the CM. How is the physics GMP for JEE Advanced Top 100? Physics GMP actually goes slightly beyond the JEE Advanced also. Naman, GMP goes slightly beyond the Advanced. Because I remember we had GMP at my time. So GMP was originally made for subjective exams. That is why you see GMP mostly comprises of subjective questions. It was originally designed for subjective IIT exams. When I took IIT JEE paper, then the GMP was more relevant then. Even then, it was slightly more difficult. Its level was slightly more difficult than the level that was asked in JEE. For today, it will be way more difficult. The questions are pretty difficult. If you can solve your GMP, then trust me, you'll be very comfortable with your JEE advanced questions. That is all I can say. It's not necessary. It's not necessary that you solve your GMP for JEE advanced these days. Okay. Why do people solve it though? People still solve this. See, if you have solved enough number of books, if you are already feeling very, very confident about any advanced level problems, it never harms you to solve slightly tougher problems, because that will only give you better clarity of concepts. I would only advise you to solve GMP only after you think you are very comfortable with all advanced level problems. If you can solve all advanced level problems of the previous years easily, then yes, go for GMP. Alright, and if you're feeling comfortable with that, then you can try GMP. So I was with FitG only earlier, so I know very well what GMP is and how tough it is. Students usually have nightmares about that. Okay, so I wouldn't advise it unless you're feeling very confident about your preparation. Alright, similarly, let's see how do you find the acceleration of any general point. Acceleration is again very simple. First, you move to the reference frame of the CM, see the acceleration of any point from the reference frame of the CM, and then you add the acceleration of the CM. So for this, a review package is alright, but review package had a lot of errors, if I remember. I think the review package, yeah, I know. The review package was made in a bit of a hurry, I think. So it had small little bits of errors. Otherwise, it was fine. The review package was fine. The level of review package is decent. But it had some errors, okay. I think there are, instead of GMP, I think it would be better if you solved Erudov. I think Erudov would be more relevant and easier than GMP. GMP would be tougher than Erudov also. Oh, that is good. That is good. So why don't you try Erudov? Have you solved Erudov? You can try Erudov. The only problem is not all the problems might be relevant to JEE. But have a teacher guide you, mark you some problems which are relevant to JEE, and I think Erudov solving. Okay. So how about the other chapters? See, there are many books that I can recommend, but depends on your comfort level. You can go for GMP also in that case. In case you have already covered your HCV, you've already covered your Erudov, then you can go for GMP. I mean, then there is no harm. Okay? If you're feeling that comfortable, if you're feeling that confident about your preparation, yes, go for GMP then. Don't worry. There are other books also for mechanics. If you're specifically asking for mechanics, there are some other books. Okay, so there is one book, I love the problem collection of that. It is called Vector Mechanics for Engineers by Beer and Johnson. If you want to try more problems on mechanics, so I can recommend this book. It's called Vector Mechanics. Vector Mechanics for Engineers by Beer and Johnson. I think, I'm not sure about the Johnson spelling. You will have to check. I think the N and H, I think, would be the other way around. But Beer and Johnson by Vector Mechanics for Engineers by Beer and Johnson, that is a wonderful book. So most of the problems here would be quite relevant. Most of the problems of Erudov were also quite relevant, you know. So you can try this book. No, please don't. See, all these are not needed these days when your JEE is objective. then these are not needed as such. But yeah, if you have that level of preparation, if you want tougher problems, if you just want to make your preparation more rigorous, then you can go for these books. Okay. All right. How about the acceleration of any point? So let's talk about the acceleration of, let's say, A. So let's see the acceleration of A in the reference frame of the CM. So what is the acceleration of A in the reference frame of CM? That would be having two components, one centripetal acceleration and another tangential acceleration. So centripetal acceleration would be omega cross VA Alright, that is how we write centripetal acceleration, or you could have just written omega square r also. But since I'm writing it in vector form, that is why I'm writing this like this, plus alpha r cross alpha. Oh, sorry, alpha cross r only. So you find the acceleration of point A with respect to the CM, and finally you will know that acceleration of A would be acceleration of A with respect to the CM plus acceleration of the CM itself. Okay. So that is how you can find the acceleration of any random point A also now. So that is what you do for analysis of general motion. So HCV plus Anurag Mishra plus Erudov mechanics plus previous year questions plus beer. Yes, for as far as mechanics is concerned, trust me, you should be fine, absolutely fine. Yes, Naman, you should be absolutely fine as far as mechanics is concerned. Don't worry. And as far as physics is concerned, you will need to score well in your other subjects also. Yes, I realize that. You said so. Yes, that would be more than sufficient. Don't worry. That would be more than sufficient. Okay. For top 100, don't worry. Then you need to work on two more things, Naman. Once you have solved all these books, that means you have your concept sorted. Okay. You would be confident about your. As I said, that this is only for mechanics. This is only a mechanics book. So solve your entire Erudov, solve your entire HC Verma, solve all the packages that you have from your coaching. That should be good enough. Okay. And if you're able to do that, then see, your concepts are fine, your concepts are strong if you've solved so many books. Then you need to focus on your speed and accuracy. If you want to come in top 100, see, the only difference is I think everybody in top 500 would have almost very similar level of conceptual understanding and clarity. What matters is that you are solving problems faster also and accurately. So after a point of time, now how do you differentiate between the top 500? Then speed and accuracy start mattering. Okay, Naman. So afterwards you will need to focus on your speed and accuracy. Trust me, that will be the key. One more thing, again, I'm deviating from my lecture, but one more thing that is very, very important is your mental state and mental prep. So, yeah, let me just get rid of this for now. That is not meant for everybody, it is only meant to be solved after Erudov. Alright, I can understand that. There is another book, Galaxy Physics, if you've heard. Yes, DK Prodigy, I think Itziorma is an excellent book, and from conceptual understanding point of view, it is sufficient for mains, but advanced you need some tougher problems. Alright. So you can try Galaxy Physics also by Ashish Ahuja sir. Alright, he has got a great collection of problems. He has picked up good problems from Erudov, from everywhere else, and from Olympiad problems also. So that book is great for your JEE Advanced and beyond that, even for your Olympiads. Alright, so you can try this. Naman. Yes, I know HC Verma theory sucks. It's very concise. So Naman, you can try galaxy physics also. Galaxy physics has got a good collection, but only after you are very comfortable in your subject, very confident, because the problems are very tough. So good for advanced plus Olympiads. So in case you are interested in Olympiads, yeah, I know that happens. Yes, of course, you should do that. IMPHO papers should be solved. Yeah, I know. I have noticed that whenever I go off topic, people are more interested then. Yes, thank you so much, guys. Let's get back to the topic of the day. So that is how you can find your acceleration and velocities of any general point. Once ACM and VCM and omega are known, so you need to find VCM, omega, alpha, and ACM. Once you know these four, you can find everything. Like we just discussed, you can find the velocity and the acceleration of any general point. No problem. Yasir, strategy for 2022. Uh, all right. It's a long way to go. Yeah, Yasir. Probably I can take another session to discuss that. This session is for 2020 aspirants. Okay. So I don't want to waste their time. In any case, they have very less time on their hands. Hi, Joey Bong. How are you? So Yasir, maybe I can have a session where I can discuss the strategy for physics for 2022 aspirants. Okay. Yes, I know. Next, once I know all this, I can also find the total momentum of a rigid body. How if you remember, the total momentum of any system of particles is always equal to the momentum of the cm. And now you easily know the momentum of the cm, which is nothing but total mass of the body times vcm. So if you knew your vcm, omega, alpha, and a, you can now find the total angular momentum also, linear momentum also. So this is your linear momentum, angular momentum also. So angular momentum also can be found now, as you realize that angular momentum of any system of particles about any point P is R of Cm with respect to P cross Pcm plus Icm omega. So I hope you remember this. I discussed this earlier. Yes, I will discuss that later. Don't worry. So now you can find the total momentum and the total angular momentum of the body. Next, you can also find the kinetic energy. Now, kinetic energy, I don't know if you guys remember this, kinetic energy of any system of particles. Always, this is a general result which is always true. Like this is the general result which is always true. This result is always true. ICM, L equals ICM omega is a special case of this, by the way. Okay, and I can prove all that, but I'm not going into the proofs. When I show this for class 11 students, I will talk about all the proofs. Don't worry. So if you're a class 11th student, you don't know how this formula came about and why we write angular momentum as I omega, I will show all the proofs there. But right now, you need to remember that this is the general formula which is always valid. I omega, L equals I omega is a special case result. Okay. Similarly, a general result of kinetic energy of any system of particles is in any reference frame S is always given by K of Cm in the reference frame of S plus K of system in the reference frame of the Cm. This is also a general result that again I can prove, but I'm not going into the proof right now. Okay, so this is also a general result that kinetic energy of any system of particles in a reference frame S is equal to the kinetic energy of the Cm in the same reference frame S plus the kinetic energy of the system in the reference frame of Cm. So now you realize I can write my total kinetic energy now. So total kinetic energy of any rigid body would be the kinetic energy of the CM. And what is the kinetic energy of the CM? That is half m VCM whole square. So that is what this term will look like, plus kinetic energy of the system in the reference frame of CM. Now for rigid bodies, you know that in the frame of CM, a rigid body can only have pure rotation. So pure rotation kinetic energy I already know. So this becomes plus half ICM omega square. So that is the result that you have for your kinetic energy of any rigid body. Alright. This is the general equation, true for even non-rigid bodies, by the way. Even if your body is non-rigid, then also you can apply this equation. For rigid bodies, this equation takes the form of this. Alright, so remember this, that finally you can find the kinetic energy of the entire rigid body as half m VCM square plus half ICM omega square. So this is what this is. This second term is half ICM omega square, is nothing but the kinetic energy of your rigid body in the reference frame of your CM. In the reference frame of the CM, the rigid body would be performing pure rotation, and I know the kinetic energy of pure rotation. Okay. So you realize that we could write the velocities of any general point, accelerations of any general point, the total momentum of any general point, the angular momentum of the entire body, the total momentum of the entire body, and the total kinetic energy of the entire body. Next, I can also use tools like angular momentum and angular impulse. Yes, Moisha. Yes, in the reference frame of the CM. In fact, that is why the kinetic energy of any body or any system of particles is always lowest in the reference frame of the CM. It comes from here. Because in the reference frame of CM, the first term will become 0. And second term, you realize, is not depending on your reference frame. You go to any reference frame, the second term is constant. The first term depends on the reference frame. That is why the kinetic energy of any system of particles is always minimum in the CM frame. Okay, you can conclude from here. K of any system is always minimum in CM frame. Alright, you know that kinetic energy is a frame dependent thing. It depends on your reference frame. You can see that from here. If you move your reference frame, then the kinetic energy of the CM from that reference frame will change. However, the second term is the kinetic energy of the system in the CM frame. So second term is frame independent. It does not depend on your reference frame from where you are looking, though the first depends on that. So when you move from one reference frame to another, this value, kinetic energy can minimum be 0. It can never be negative. And in the frame of the CM itself, it is always 0. So that is why you get this conclusion that kinetic energy of any system is always minimum in the CM frame. Remember this. Okay, I think yeah. Alright. Next, you can also talk about angular impulse and angular momentum. The way to define angular impulse is that angular impulse is defined as integral of tau dt, where tau is the torque, and you're integrating tau dt from some time interval t1 to t2, and this is called angular impulse, angular momentum theorem. Angular impulse is always equal to the change in angular momentum. And what is angular impulse? How do I calculate? Angular impulse can also be related to linear impulse as this. Alright, it is defined as the moment of linear impulse. So angular impulse about some point O would be the position vector of the point where a linear impulse is acting with respect to O into the linear impulse. Okay. Yes, there is one question. So you can apply angular impulse, angular momentum theorem also for your analysis. Let's go over one problem. Okay, so now I wanted to have a detailed discussion of this problem. I wanted to have a very detailed discussion of this problem so that I can show you some differences about how we can analyze things and how we cannot analyze things, or what we should be careful about when analyzing any question. So why don't you guys do one thing? Take a screenshot of this, solve this on your own at home. All right. No, I think I'm already over time. The class was meant to get over at 10:15. If you look at the schedule, this class was meant to be held from 9:15 to 10:15. Already, I have extended it for almost 45 minutes now. So just try this problem on your own. Plus the discussion, the kind of discussion that I want to have with this problem would take a lot of time. All right. Let's get back tomorrow. I also need to get some sleep. It's already very late. I still haven't had my dinner also, by the way. So round figure. Okay. All right. So why don't you try this problem? Try this problem and give me your answers. That will itself take another 5-10 minutes, right? I hope you understand, Moisha. If I give you time to try this problem also, it will take at least 5 minutes for you to try this. And when I start the discussion after 5 minutes, I won't be able to wrap it up in the next 5 minutes. So take a screenshot of this problem, try this at your home. So let me read out the problem once. The problem says a plank of length 2L and mass small m, mass capital M lies on a frictionless table. Now a ball of mass small m and speed v0 strikes its end as shown. You to find the final velocity of the ball Vf, assuming that mechanical energy is conserved in this collision. Yes, thank you so much. So let me just read out this question once. So this plank of length 2L is lying on a frictionless table. It has a mass of capital M. A small ball of mass small m moving with a velocity v0 strikes at end A. Right. Now you've been told that in this collision, the total mechanical energy remains conserved. Which means what kind of collision is this? It is a perfectly elastic collision. Okay. Now after the collision, you have to find the final speed of the ball and also find the speeds of ends A and B of this plank or rod. So trust me, this will take a lot of time. This is a complicated problem. This will take some time for solving and I will discuss this tomorrow, don't worry. So take a screenshot. I hope you have done that. Yes, I will tell you about that. Okay, so you can see I left 2 slides for the solution of this. In any case, so that is where I want to wrap it up for today. Before I leave you guys, let me remind you that you can get your Unacademy subscriptions using following these simple steps. Go to the plus section and select your goal as IIT JEE and then click on get subscription. Now let me once remind you one more time that you can get your Unacademy subscriptions using my code RDLive. Okay, so if you want to study from me and if you like my teaching, then you can use this code to get your subscriptions to join my courses. This code will also give you an additional 10% off. Now if you liked this video, if you thought you learned something new today, then press the like button and share it with your friends and share it with more and more friends, because I don't think you guys are sharing with enough friends. I barely get any live viewers. Okay, so I would like to have slightly bigger viewership at least, so that there is more competition, more interaction. All right. So anyhow, don't forget to press the bell icon to get the notifications of all the lectures, and the PDF of all the slides used in today's lecture will also be available for download. You can check that in the description box by tomorrow. Next, this is the new timetable. In case you weren't aware, please check out the new timetable. Join us on the Telegram app for all the notifications about JEE English channel. Now, this is the details which you guys have been asking. I have created a Telegram group by the name JEE Physics. This is the link for that Telegram group. You can join this group using this link, and you can also find me. My user ID on Telegram is Rohit_Dixit. Yes, I know, but so should you also, right? I don't think you guys are doing your bit also. They should definitely. So this is how you can connect with me on Telegram app. All right. So this is it for me. This is it for the day from my side. So I'll take your leave, and before leaving, let me remind you one more time. Don't forget to get your Unacademy subscriptions using the code RDLive and get additional 10% off. So good night and bye bye. I'll see you guys tomorrow. All right, and we will carry forward our discussion tomorrow only. So don't worry about it. For you guys 2020 aspirants, I'm conducting classes daily. For 2021 and 2022 aspirants, I'm having it on alternate days. So don't worry, you're getting enough time. Alright. Alright, thank you guys. So that'll be it. Bye bye.